Hello. I want to make sure that I give you a couple of examples of things to do for accelerated motion. We had a couple problems we went over in class. Since this is going to be a virtual assignment, I want to refresh your memory on that. So if we look over here, we've got two formulas really that go with acceleration. Acceleration, and this should be formula 3 on your formula sheet. Acceleration is equal to final velocity minus initial velocity, and I've said it's over time, but really it's a time interval. So if you have a velocity time graph and you notice that the velocity is changing at several places along the graph, you would only find this out for a particular interval of time. There are other ways to rearrange this. So if I want to find final velocity, it's equal to initial velocity plus acceleration times time. Remember, so that's plus, and these two are multiplied together. Remember, acceleration is measured in meters per second. Time is measured in seconds. Velocities are measured in just meters per second. If I want to find an initial velocity, I could say final velocity minus acceleration times time. And accelerations can be positive or negative, and velocities can be positive or negative as well. Finally, if I want to solve for the time, I would just swap that out with the acceleration over here algebraically. So time is equal to final velocity minus initial velocity divided by acceleration. This is the main one that should be on your formula sheet for formula 3. These two, I think I said you can put at the bottom. This one, I think you might be able to figure out honestly without necessarily writing it down like that. So anyhow, I'll take that off for right now. The other formula that we tend to use is formula 4. And that's for displacement and acceleration. So we say x, which is our symbol for displacement, 1/2 times acceleration times time squared. We have to be a little bit careful about this because our units for acceleration are meters per second. Time, however, we would square. So that's seconds times seconds. And there can be an algebraic rearrangement for this to solve for acceleration or time. Probably won't do that too much in this particular course. So at any rate, let's try an example. Let's say we have an object that's starting with an initial velocity of 12 meters per second. And let's say that we've got something where we've figured out that its acceleration is 3 meters per second. And we want to figure out the final velocity. Well, in order to know that, I need to know how much time it's taking to accelerate at 3 meters per second. So let's say that our time interval here was 4 seconds. Let's say 10 seconds. So what that says is for every 1 second that the object's accelerating, it's speeding up 3 meters per second. So if my initial velocity was 12 meters per second, after 1 second of acceleration, it would be 12 plus 3, 15 meters per second. After 2 seconds of accelerating at this, it would be 12 plus 3 plus another 3, and that would be 18 meters per second. So overall, I could use this formula here, this one up here, which is V final is equal to V initial plus acceleration times time. So I would say with this, V final is equal to V initial, that's 12 meters per second, plus my acceleration of 3 meters per second, multiplied by a time interval of 10 seconds. 3 times 10 is 30. 30 plus 12 is 42. So my final answer, 42 meters per second. And make sure you circle that and put units on it, and that'd be good. Now let's take a look at this one over here. Let's say we've got an object that's accelerating due to gravity, and with gravity, objects accelerate all at the same rate close to the surface of the Earth. That's somewhere around 9.8 meters per second, or 10 meters per second. You can use either one of those. I think on the formula sheet it says 9.8. So let's say an object is dropped. From a building or something like that, and hits the ground 3 seconds later. How high would the object be that it's dropping from? Well, again, we're just going to come back and use this straightforward. Even though it's vertical, which is in the y direction, we'll still use this x for displacement. So we'll say x is equal to 1/2 at squared. But here, the acceleration due to gravity, we're going to say is 9.8 meters per second. This time is going to be 3 seconds. So I'm going to say 1/2 9.8 meters per second times 3 seconds squared. Well, 1/2 times 9.8 is 4.9. 3 squared is 9. So you probably have to put that in a calculator. I'm going to think 9 times 4.9, a little less than 45. I think it's 44.1. So let me check that. Again, in my calculator, I would just put 0.5 times 9.8. If you don't have the square button, you could just do times 3 times 3. And it is 44.1 meters. So hopefully these are helpful as an examples. Just take a look at the information that's given to you in a problem. Make sure you write it down. And make sure you write down a general formula first, then plug in numbers with units, then final answer with units, which will be circled. And that'll help you organize your work and get partial credit even if you miss something along the way. Thanks.